Right, hey guys. So today we're going to be covering a highly requested topic on how to sign smart contract transactions using Hashpack, using Hashconnect, and of course it's all going to be on the Hedera blockchain. So the kind of outline of this video will be one, creating the smart contract. It's just going to be a very basic one, obviously done in Solidity. Two, uploading that smart contract onto the Hedera network, and then three, using using just a Hedera account authenticated with Hashpack, a Hashpack wallet essentially, and signing transactions to that smart contract from our wallet. So there's going to be quite a lot in this video. A lot of people have been asking for it. I apologize for the delay to everyone. I've been very busy, and obviously YouTube isn't kind of my priority at the moment. It's just kind of, I do videos for fun essentially. But yeah, today is the day where this comes out. I hope you guys find it interesting, and let's get started. So yeah, as I said, to begin with, we're going to be coding our smart contract now. I like to do my smart contracts in Remix. It's just an online programming interface where it also automatically compiles the contract, and you can test it out, and you can do just test it out to see that it's working. So in our contracts file, I'm just going to delete these. So I'm just going to delete the files that we've already got, just because they're not important. And before I do that, I'm going to copy and paste this line. Actually, no, well, copy and paste this line. I'll delete this final contract. I'll explain why I've copy and pasted that line. But if we just say test contract.sol.sol means it's a Solidity file. And I'm going to paste in these lines here. So when you're writing any smart contract, you need to first of all add a license, and second of all kind of add which version of Solidity we're going to be using. So this means it compile anything between version 7 and version 9, or 0.7, 0.9. I've got a little mini series on kind of smart contracts on my account. I think it's all in a library or whatever, but it's on my account if you just want to kind of learn about the basics of smart contracts. But essentially, the way that we start off a smart contracts is we write the name of the contract, which we're going to call test contract as well, keep it in line with the file name. And well, this is where we begin. So we're just going to write a very, very, very basic smart contract. It's not going to have a constructor. It's not going to have, pretty much anything yet. It's just going to have one option where we can send money to the contract, and then we can just check on Dragon Glass. We can then check on Dragon Glass how much money the smart contract has. So it'll be a test net. And I believe when you type in the contract ID, you can check kind of the information within that. But let's get back to this, actually writing the contract. So it's going to have a function which will be the send to contract function. Not going to take in any arguments. It's going to be an external function, and it's also going to be payable because it means we're going to be sending money to the contract. And then when it comes, this is actually all you need for a send money to the contract function, because we just need to let the contract know that we've got a function called send to contract, which is the payable function. The user decides how much they send to the contract, and so if I save this, that automatically compiles it. Just press Control S, and if we go over here into the deploy and run transactions section, I'm just using the virtual machine, so I get all these test accounts here. Now, if we deploy this contract, at the moment we've only got the send to contract button. However, we might want to see how much money the contract has. So to do that, we'll create a new function. We'll say, okay, this is the check contract balance, and it's not actually going to take in any variables. This is also going to be an external function, or do we want it public or external? I can't, to be honest, I can't remember the two off the top of my head. There's 4 types of functions. Yeah, you've got private functions, you've got public functions, you've got external, and you've got pure functions, I think it is. Now they've each kind of got their own niches. For this current thing, I think external or public to be safe will do. But okay, again, this is just it's going to get the contracts. So we're going to be saying address this dot balance, and how do we return that? Right, so yeah, we literally just press return. I haven't done smart contracts in a while, to be honest, so I think I need a recap of my own videos. But this should return the current balance. So again, if I save it, got to end the lines with semicolons. That's very important. And what else? We also need to say that it returns, and this is going to return an unsigned integer. So that's now state mutability restricted to view. Right, that's the other one. So public view function, because it's not got any kind of logic. We're just reading something. We're not writing anything. It can be a view function. Right. Okay. So let's delete this old contract. We'll deploy the new one. That should be the new one. It's got the new function. So first, when I check contract, it's got nothing available. Yeah, we haven't got anything to the contract. Now, if I want to, from this account, if I want to send some Ethereum to it, let's just send 1 ETH. Send to contract. I now check contract, and we've now got 1,000 Wei. Not 1,000. 1 times by 10 to the 18 Wei. Wei is a subunit of Ether. So this is going to be our contract. It's very, very straightforward. We can send money to the contract, and we can check how much money the contract has. Obviously, a contract will not be this basic. An example of a previous contract I've done can be found here, which is for this hash raffle idea I had. And it's a bit more complex. We've got the send and add participant to the raffle, which is essentially a list of addresses. And then it checks whether the message value sent is greater than a certain amount. If it's less than the specific amount, then we're giving an error message. If it's successful, we then push the player into the list. We've then got the process winner. So once it has enough players, then once there's enough players in the list of addresses, that's how we know that there's enough players. It will then take in an argument which we can pass in with JavaScript of a randomly picked integer between 0 and the length of the contract, length of the array, and it will make the recent winner the random player, and then it will send. Yeah, there we go. So this then sends the amount in the contract, address.this.balance, the amount within the contract, it sends that to the recent winner. So this is just an example of something that I've done. Some contracts can be 1,000 lines long. There's a lot of flexibility with them. So, right, okay, we've got our contract. Now we need to get the relevant byte information from it. This is so that we can then update it to the Hedera network. If I show you on the Hedera docs, we need to store the smart contract bytecode on Hedera. This is how we put it onto the Hedera blockchain. So we use that during the file create transaction. But to begin with, we actually just need to get the bytecode itself. So the bytecode can be found in the test contract JSON, and it's this. This is the relevant information. This is the bytecode corresponding to our contract. So I'm just going to copy that. I'm then going to set up just a little front end app, and we can get started in the next step. Right, so I've just created a folder, and I'm going to create a React app inside. So using npx create React -app, and it's going to be in this directory. So I'm just going to put dot. Going to build the React app. Then I'm going to install the relevant packages we need, the relevant npm modules, and after that we can get cracking with the code. Right, so we've got our React app set up. I'm now also going to install some of the dependencies. So I'm going to install the Hashconnect dependency. Obviously, we're going to be using that to connect our Hashpack wallet and sign transactions with that, and also the Hashgraph /SDK. So we're going to be installing those two things. Now, of course, as you can tell, I'm using a JavaScript library. So I'm using React. Now, the reason why things like React and Vue, for example, are very popular is because whenever you're using Node modules, behind the hood, React and whatever library, they kind of compile and source all of the correct Node modules into the public folder. They do it correctly, so that you're able to bring the functionality that the modules have. Now, if you're just doing a straight HTML JavaScript website, you're going to need to be able to transpile the code yourself, transpile these node modules into a form, into a folder, into a file, a JavaScript file, which you can then kind of add to your server. Because obviously, when you're putting something on the website, it's got no way of pulling these node modules. It needs to be on the same computer. At the moment, on our local host, we're all in the same computer. But when you start publishing to the web, then you need to have the files compiled into a local file on the web server. Now, you can do this using things like Webpack. I did it for the first time a couple of days ago. But when you're using things like React or other libraries, you don't actually need to worry about doing it. It does it all by itself. Okay, so we've installed those two things now. So if we check into our node modules, we're going to have the Hashpack somewhere over here, probably come past that by. Yeah, Hashgraph, and then we've got the Hashconnect one a bit further down. So yes, right. Before we get started, I mentioned at the beginning of the video, we need to actually get the smart contract onto the server. We need to get the smart contracts onto the Hedera Hashgraph, I should say. So before we do anything, I'm just going to create an index.js file just over here. And this is where I'm just going to write the code in order to get the file shared up. Right, so now that we're going to be deploying the contract onto the distributed Hashgraph ledger, obviously, first place to look at is the documentation. Now, in the try examples, deploy your first contract documentation, they add the contract in a slightly longer way than is necessary. So they do it in two steps. They do it in the file create transaction, which is where you set the contents of the bytecode. That's what I've already copied and pasted. Well, copied, haven't pasted it yet. And then you deploy the contract. So you then do a contract create transaction. This is where you set the constructor parameters. Obviously, our function does not have any constructor parameters. However, you can use this new create contract flow command. So then this is where you set the bytecode, you set the gas, and then you can get the contract ID, rather than having to get the bytecode file ID, add the bytecode file, and then get the contract ID. So it kind of does the two things in one. I don't know whether if for example you have, okay, contract create transaction. So yeah, with the contract create flow, it doesn't seem like there is a set constructor variables call. So I think if you've got a constructor method inside your contract, you do need to use the contract create transaction, get the bytecode file ID, and add that into there, and then you can do the set constructor parameters. But like I said, because ours does not have a contract, we're going to be using this particular method. So in our file, first of all, we're just going to say we're going to import. And what are we going to import? We're going to need to import so we're going to, what's happened here? So yeah, we're going to need to import the contract create flow. So contract create flow, and that's going to be from at hashgraph/SDK. We also need to sign it with, also going to need to sign it and execute it with the client. So I'm going to take in the account ID, and I'm also going to be taking in private key, so that we can convert our client's keys into the correct form to then use it for signing. Also going to be importing client, and I'm going to create a variable called bytecode. So const bytecode, and that equals, no, I don't copy and paste it. So go back into Remix ID. This is the bytecode. Copy that, paste it in there. So this is our contract bytecode. We also need to configure our client. So obviously, you require the account ID and you require the private key. I'm just going to go sort that out quickly now. So yeah, if you haven't already, when you're just doing stuff in the testnet, create a Hedera developer account, because this gives you an account ID and private key, which gets topped up with 10,000 HBAR every day. I'm not going to show my whole private key, but I will. I'm not going to put any environment variables or anything. So what I'm going to do is I'm just going to have my account ID and my private key up here. I'm just going to hide them. But obviously in production, you want to have them either on the back end and encrypted or whatever. The contract, this client is just to sign for the transactions. The person will still be using Hashpack to sign their own transactions, but the client will cover the transaction fees. Right, so I've got them up here. I'm now going to create our client variable. So const client equals client.set for testnet.set operator, and then it's going to be taking in the key. So it's going to be taking the account ID.from string, and then my account ID. That's just what I've called the variable further above. And it's also then going to be taking in the private key. So we're going to be saying private key. That is what it's called, yeah. Private key dot from string, and that's going to be the private key in there. Let's just neaten this up a bit. A bit messy, but that's all right. So it's going to be taking the account ID and the private key. I think that is the correct way of doing it. We'll find out. Right, okay, so now we can begin making our functions as well. So we're just going to create an asynchronous function, which is going to be called upload contract. That's going to be equal to an async function. It's not going to take any variables. And what will it do? So if we go back to the docs, we can just kind of take this as our guide. So we need to create the contract create transaction. So const contract tx equals new create contract create flow. Now we then need to add the property. So we're going to set gas. Of course, we need to set gas for it. This gas is needed for every smart contract call. So we'll just set, like I said, about 100,000 to be safe. Of course, you can experiment to find out what the perfect zone is. And then we're going to be setting the bytecode, and that's going to be equal to the bytecode above. We're then going to get a response. So const contract response, and that's going to be given in us in the contract tx dot execute, and we're executing with the client. So that's obviously we've set the client up over there. Then we need to get the receipt, and then we can get the ID from that receipt. So we do need to get the receipt, even though it's now been uploaded. This is officially uploading it to the network. We still need to get the receipt so that we can have the contract ID. So we'll say again, const receipt, and that's going to equal. First of all, do we need to await this? No, we don't need to await it. I think we may do. I'll just copy and paste that. And it's not, it's the contract res dot client. Okay, so we've got that, and now we want to get this line here. Const new contract ID, await receipt, blah blah blah. Okay, and then we just console log. We'll just then console log the account ID. So console dot log, and then we're going to say our contract ID is, and then we inject it using this method. Save that. We can then run this file after calling that upload contract function. Should get the contract ID logged out to us, assuming that everything's been set up correctly. So let's try that now. Go node index and cannot use import. Right. Okay. So we need to use require. So we'll say const and then equals require. Of course, we're using Node.js, so in Node.js you need to use the require functions. And it looks like it's been done correctly. So I did configure it all right over there. There we go. Our contract ID is 0.0 blah blah blah. Like I said, we can actually now check this on the Dragon Glass. So if we paste it into there, and it's been corrected. Look at that! How it's just amazing how quick it is. Actually, just amazing. So at the moment, I think the amount refers to how much the contract has. There's nothing in the contract at the moment, but we can send stuff to that contract. We can then either, with two ways, we can check the amount here, or we can check the amount by calling the check amount function, which we have hard coded into the smart contracts over here. Check contract balance. Right, so the next steps are going to be setting up kind of an interface to, first of all, sign and connect your Hashpack wallet, and second of all, call a transaction, call a contract function. Also, we don't even need this file at all anymore, so I'm just going to delete it. I've copied the contract ID. That's all we need for now, but I'm just going to delete this file. It's not that important. I'm also just going to start our React server, not by calling npm strat, by calling npm start. And I'm just going to copy and paste kind of code which I've already had done videos on how to sign up and connect your Hashpack wallet. Obviously, you need to pair it before you can sign with it, of course. So that I'm just going to skip over, and then we'll get straight into signing the actual contract call functions. Right, so I've just got the pairing of the Hashpack wallet set up. Now, as you can see, we're using import and we're using import-export statements over here. That's because when React compiles it, again, under the hood, it compiles it all into the correct format and it will change it into the require format, essentially. So we can use import-export while using React. We've initialized our Hashconnect class, so we've now got the Hashconnect object, and we can use all of these methods within it to connect our thing. Now, I'm not going to be doing it using the connect local wallet ping. I'm going to be using it doing the pairing string, and that's just because the ping only works when you're in a HTTPS server. Because I'm just doing this all locally, it's HTTP, but that's not too bad. So the way that we're going to get around that is I've got this save data variable, the save data object over here, which I'm going to be returning. Inside it is the pairing string. And over in our app.js, what I'm going to do is I'm going to say, so firstly, I like to do it at the top just because it's kind of most important. So import React, and then we're also going to be importing use state. And we're going to say that's from React. Okay, so now we can set our save data, and we're going to say set save data, and this is going to be equal to use state. To begin with, it's just going to be an empty object. But when we add this function, so we're going to add a button here, which will be saying wallet. Have we exported this? Yeah, so I'm now going to import from our file. I'm going to import pair client, and that's going to be from Hashgraph. So we're importing that pair client function. On click, we're going to have a function over here. So what this is going to do is it's going to, we'll say, okay, const save data equals pair client. So this is going to be, we're going to call that pair client function. It returns the save data. And then what I'm going to be doing, once we get that, we're going to be saying await first of all, because it's an asynchronous function. It means we've got to make this asynchronous. And once that's been received, we're going to say set save data. I'm going to let that equal save data. So the reason why, what's that? Set save data is, that's why. So yeah, once this save data has been retrieved after the asynchronous function has been executed, then we can save that into our state, and we can then display the string. So we can then say once save data has been populated, once save data is true. At the moment it's false because it's an empty object, or is it do empty? Right, we'll test this out. I can't remember whether empty objects are true or false. And then we'll say and then we can give this pairing string, which will be save data dot. I'm pretty sure I've just called it pairing string. Yeah. So save data dot pairing string. Now, yeah, let's just run this pair wallet function and see what happens. Okay, cool. Okay, nice. It's worked perfectly. So this is our pairing string. Also, at the moment, it's just going off. So I'm just going to add a quick bit of CSS code to this paragraph here. Again, we probably do this in a separate CSS file, but I'm just going to do it in line. So we're going to say style, and then we're going to say overflow x, and we're going to say that equals scroll. So it should serve that. And yeah, there we go. Now we have, still looking a bit dodgy. Pair wallet. Okay, cool. So I just added a max width to it as well. Max width of 90 view widths. And now we've got the pairing string over here. So of course, it doesn't really matter. Again, typically in production, I would recommend using the ping method, where you click the button and automatically your Hashpack opens up. Alternatively, you can use this string though, so that's perfectly fine. So if I now open up my Hashpack wallet, I can then go into enter my password. I then go test one, select wallet. I can then add a pairing string here, so I'll copy and paste this. Copy, paste. I haven't checked. This is just what the variable is. Let's change quickly the app data. So we'll change that to test smart contracts. It's not going to update now, but for sequential times. So we approve that, and then we should also get a response in our console to show it's been successful. So yeah, this message event is trusted true. So we've now successfully paired our smart wallet, our Hashpack wallet, onto our browser. So now we can get on to creating the functions which actually begin what's the word? Interacting with the smart contract, which has already been stored in the Hedera blockchain. Right, so we're going to have to add a few more. Well, we've already imported the Hashconnect stuff, but we haven't imported the relevant Hashgraph stuff. So we'll import that now. We'll import contract ID. We need to convert our contract ID in the correct form to then have it processed by the Hashgraph functions, and we also need to do contract execute transaction. Yeah. Contract execute transaction. This will be what we use to call the functions inside it. Now we're importing these from @hashgraph/SDK. So first of all, because we're going to be signing it with this Hashconnect, we need to essentially use the same Hashconnect object that we've initialized. If you create a new file and you then repeat this Hashconnect equals new Hashconnect, if you do this in a new file, you're actually going to get some errors because it needs to be the same initialized Hashconnect object. Now, if you want to keep your files in like a very modular fashion, if you want to separate each of your files, that's fair enough. What I believe you can do is you can initialize this Hashconnect object in a separate file and then just export that Hashconnect object, import it into all of your other ones, but do not do const Hashconnect. Do not redeclare this essentially in every new file you've got, because it needs to be the same one Hashconnect object in order to use the signing features. I hope you understand that. I hope that's made sense. I don't know if I've explained it very well, but nonetheless, we're going to create a new function. It's going to be export, and then it's going to be, what should we call it? Contract signing function. It's also going to be asynchronous, not going to take in any variables, and yeah, let's just begin with it. Have I spent everything there? Right, I have. Okay, right. So before we get started, let's just go over to the contract. So the contract is of contract ID this. So we're just going to say const contract ID equals contract.id.from string, and it's from this is it. So now we need to, in our contract signing function, first of all, because we're going to be signing it using the Hashpack and Hashconnect, we're going to need to be using the signer provider functionality. So that's kind of built in. I'm just going to copy and paste what I've got from a previous project, but this is what you need to do. So you need to say const provider equals Hashconnect get provider. We're using the testnet, and it's going to be from the save data.topic. And then our account ID is actually going to be set. So we populate the account ID into this save data paired accounts. Now, because we've only signed up with one, we can just say save data.paired accounts, and it's just going to be the 0th index. Right, okay, so we've got that. So this is our provider. We're then saying const signer equals hashconnect.get signer, and then entering that provider in. The signer is what we're going to be using to sign all the transactions. So now we're going to create our send money function. So const send money, send hbar. And when you send it, I believe it sends it in tinybar. Similarly to how when, oh, for God's sake. Just realized it's not been on. So similarly to how when we send stuff using like Ethereum, it shows it all in way. Equally, it sends it all in hbar and tinybar when it comes to smart contracts on the Hedera network. So we're going to be saying const send hbar transaction equals new contract execute transaction. We need to add what the ID is, so set contract ID, and that's just going to be our contract ID. Again, if we were to put in just a string like that, it's not going to work because we need to make it a contract ID object. So we need to say contract ID dot from string, and then we get it in the correct format. So we've got the set contract ID. We're then going to want to set the gas because obviously it's a smart contract. So again, to be safe, I'm just going to say 100,000. I think you can do less. Set payable amount because we know that we're going to be sending it to a payable function. So we need to set a payable amount and send the payable amount. For this, I believe it sends in hbar. So I'm just going to send 10 hbar. And if you want to do tinybar, you can do like import the hbar class from the Hashgraph SDK and do like hbar.from tinybars or something like that. And then finally, we need to set the function. So we need to tell which function we're going to be calling. Now, if we check over in our smart contract file, we can check what we've called the function. And we have called it send to contract. So that's a good name. Now, you may have seen there was another parameter which was set function parameters. This is if your function has any arguments, then you can also set the arguments, which is very useful because obviously if you have a function which requires arguments, you're going to need to give it arguments. None of our functions have arguments, fortunately. But that does not matter. So if I keep going with this, we're not going to set any of that. We're going to be sending 10 HBAR, and it's going to be the send contract function. And I think we need to do freeze with signer. So you're probably used to doing freeze with, or maybe just freeze, but we're doing freeze with signer because we're using the signer provider API. And we're just going to pass in the signer in that case. So that's been done. Now we can do our result. So the result is going to be const result equals send HBAR transaction, and we need to await it. And that's going to be then execute with signer. So we're executing it with the signer. That means that the signer, or the person that's connected to the Hashpack wallet, they're going to be paying for these particular fees. They're also going to be paying that 10 HBAR. And I believe that is all we need to do. So to be honest, because we're not actually going to do anything with this result, I'm just going to delete that, and I'm just going to say await send HBAR transaction. Once this is called, that's going to do the job. We're going to get popped up with our HBAR, and that should be it. So yeah, we're also going to import our contract signing function. We'll create a new button. So button on click, and this one we can just enter it in because we're not doing anything else with it. We're not returning anything. We don't need to do anything more. So this is going to be send HBAR to contract. If we save that, I believe we should be completely good to go. So we're going to go back over to our React app. I'll just refresh it. And so pair wallet, copy and paste this string, delete the old connected app. Now, because we've changed it, test smart contract, there we go. So test one, approve, send HBAR to contract. I don't know why I didn't do it in the header, that's why. Okay, so send HBAR to contract. I've clicked that, nothing's happened. Let's check the console. Must have been an error. So send.execute with signer is not a function. Right, so I think this is because we didn't say await over here. So yeah, we've done freeze with signer. We need to await this. Essentially, the send HBAR TX isn't properly aligned because we haven't done it asynchronously. So we need to get the HBAR TX before executing with the signer, because otherwise we can't execute with the signer. I'm also just for looking nice, I'm just going to add it in there just to make it look a bit nicer. So we've got the HBAR sent to contract. Okay, I'll refresh everything again. We're going to need to repair our wallet. If you want to do this without having to refresh every time, then you can save that save data variable, that save data object. You can save it into the browser. So again, we'll just click pair wallet, connect that, test one, approve. Now, there we go. Good. Okay. So execute smart contract, test smart contract. We'd like you to execute smart contract. Approve. Done. Now, have I sent that 10 HBAR? Let's have a look. No. So I did, perhaps. Oh, this is all from the other. Right, let's refresh. Okay, cool. Sent 10 HBAR to the smart contract. Wicked. So that 0.566, that's just the fees. If we were to execute it with the client, then I believe it would only be 10 from, I'm not sure actually. Oh, that's okay. I'm not sure about that. But nonetheless, because we're doing it on the service, because we're doing it on the client side, on the front end side. Sorry, I've just realized there's a bit of confusion. When I say client, sometimes I'm referring to the set client, which pays the fees, from the testnet, account, which gets 10,000 HBAR every day. Obviously, sometimes the client means the actual user on the front end. So the actual user on the front end, we're going to want them to pay the fees, just because otherwise you need to send the bytecode to the server side in order to sign it with X account, because obviously we don't want this account we don't want their private keys and signing keys to be on the client side. We want it to be secure on the server side. But if we can now check, firstly, we can check doing the dragon glass. So if I refresh this, nice. So we've got 1 billion tiny bar, which is, I'm assuming, 10 H bar. That's been sent to the contract. So if we have a look at the contract itself, so we can have a look at all the contract calls, the contract create, which is the initial one, payer ID 195. So that's the one that I've just sent. And then this is obviously the one which paid for the contract create. So as you can see, it's all public, it's all decentralized, it's all totally brilliant. I think it's just amazing, this technology. I'm gonna do one final little thing. I'm going to show you how to we'll call this check contract balance, and we'll actually get the return value, and then we're going to print it out onto the screen, because that's also quite a useful thing to do. So this will be doing, again, using a slightly new function, but we'll get into that now. So because our function for checking the contract balance is a view function where we're only reading things, we're not writing anything to the contract, we're not changing the state, it remains totally the same, we're just returning a value. We're not going to be using the contract execute transaction function, we're going to be using the query function. So where's it gone? So yeah, we'll be doing the contract call query. So again, we've always got set gas. The contract ID we've already got. The set function is going to be, in our instance, the check contract balance function, and then set query payment. I'm not sure about this. I don't think I've used this before. Let me just confirm. Yeah, so upon further looking in the SDK section, this is, to be honest, this is what I'd recommend looking at. Once you're kind of familiar with the examples, I'd recommend looking and taking these for your advice, just because it's a lot more in depth. It doesn't say anywhere that you need to set a HBAR amount. So I think, for example, in the example demonstration, it's because of something specific to the contract. We just need to set the contract ID, set the gas, and then set the function. And then we just need to get the unsigned integer. So they're saying get string, we'll be getting a uint because that's what we're returning. If we again go over, we're returning a uint. The balance is always an unsigned integer. You can't have a negative balance. But I did also notice that in this, so in get smart contract information, we can actually find out how much the balance of the smart contract is just by using new contract info query. So that's something you could alternatively do. That would mean that you can get the balance without having to have your own check contract balance function. But because we've done it this way, I'm just going to show you how to do it, because this check contract balance function could be substituted for anything else where you may need to return information from a contract. So we will begin by exporting a new function. We'll say the const check contract balance. It's going to be asynchronous again, not taking any arguments, and then I believe we're still going to need to sign for it, and we'll still sign for it using the our our contract signer provider stuff. So we'll still use it with the client side, the person on the website, and then let's say const query tx equals equals new contract. Oh, that's the wrong one. So yeah, new contract query call, contract call query. Apologies for that, my old man just called me. So yeah, so we need to get this new contract call query. Obviously we need to import it. So let's import it from the Hashgraph SDK. Why does that take so long? Okay, so we've got that. Now, what do we need to pass in as the parameter? So we need to set the contract ID. We need to set the gas, and then we need to set the function. So set contract ID. That's just contract ID. We've already got that. And we're also going to set the gas, which will just do 100,000 again. Any excess gas gets refunded, so it doesn't really matter. and then we want to set function. Now the function is check contract balance, and that returns a uint. So we'll see, need to await that. So synchronous. Right, I'm just going to reference back to the docs again. So we've got that. Then we've got the contract call result. So const result equals await, and then that's going to be the query dot tx dot execute with signer. That's going to then take in the signer. Of course, you're probably familiar with execute with and then just using the client, execute with client, but no, we're using the signer. And then from our result or response, we can then get the actual information. So we'll say const balance equals response dot get uint. So just get uint with nothing. Get uint 256, we'll say, and it's going to be taking in 0, I believe, as the argument. Then we can, well, let's just console log that. We could alternatively return it and then inject it into our HTML into our page using a similar method that I did above with this pair client and returning the pairing string. Could do it that way, but for now we'll just console log it. And actually, I'm going to do it using this way, using literals, string literals or something. The contract balance is, let's save that, go over to our website. I believe, again, this should all be correct. So we now actually just need to obviously bring it over into our website. So we'll add another button. And we'll say button on click. It's going to be calling this check contract balance. So let's import that. On click contract balance, check balance of contract. Save that. Refresh. So at the moment, if I was to press either send hbar to contract or check balance, because we're not actually paired, it will just cause an error. Same error should occur here. Yep. So let's pair the wallet again. Cool. And we've already sent hbar to it, so it should have a contract balance. And some things, we need to sign it, of course, so we'll approve it. And then cannot get properties of null, reading get uint 256. Right, so we are almost there. We've signed it. There's just a little error on this side of things, and it may be because I haven't specified that we're returning a uint 256 over here. So obviously by changing that to uint 256, we then actually have to create a new bytecode, because it will generate a new bytecode and then sign it and then upload it again. So I'm going to see if there's a way around it. Right, so I've just been fiddling around with this particular issue that's occurred, and essentially when I had it with execute with signer, then we get an error. Now I'll refresh it and demonstrate it. I think I've already shown it in the video. However, this is something that I haven't come across yet. But essentially, if we do this now and we sign up and we call the check balance of contract, approve it, we get an error back. However, when I then change it onto being, oops, shouldn't show that. when we go to execute it with the client, and we don't get this error, and we actually do get a response, which is really weird. So to be honest, I don't know why. I don't know why this is happening. I'm going to pop a message into the Hedera Hashgraph Hashconnect community, see if there's anything about that. Because as you can see, if I pair the wallet, which we don't actually need to do, we check the balance of the contract. The contract balance is 0. Now, this is because I created a new contract and uploaded it, and I created it with returning UN256 to see if that was the issue. That was not the issue. However, let's send money to the contract. So we'll send 10 HBAR. This is being done from this side. So we'll execute it. Done. All successful. We can check the history. And our 10 HBAR contract should come. Now when we check the balance, we get that. So yeah, bit weird. I don't know why it's not working when we go execute with signer and use the signer. Because obviously over here, this is how we're doing the whole thing. But yeah, this is something that I'm gonna bring up in the community. See if there's been any understanding as to why that is. However, in this video, we have covered how to sign a transaction with the signer. Now, this is typically going to be more useful of use, and this we can do with the signer. It's when we want to receive or check the contract balance, for example, we want to get a return value. We doesn't seem that we're able to do it with the signer. So yeah, interesting. I've learned something new myself today. Of course, to be honest, I think in a situation where you do want to retrieve some information from the client, from the contract, it makes sense for it to be signed with this client. Again, not the client on the front end, the client of the set client over here. The operator is probably a better word of putting it. But yeah, that's kind of today's video. It's been quite long. So yeah, appreciate you sticking through and hope you learned something new. Any questions, stick them in the chat below, and yeah, I'll do my best to help out. Have a good day.